Trigonometry. We are going to practice O-level maths past exam paper questions about trigonometry from the series May-June 2024, both the variants. Let's begin. May-June 2024, Paper 2, Variant 1. And the first question involving trigonometry is this. ABCDE is a pentagon. And a pentagon is a figure that has 5 straight sides. So ABCDE has 5 sides. 1, 2, 3, 4, 5. So it's a pentagon. Now this pentagon is made up of 2 other shapes. One is this triangle BCD, which is a non-right angled triangle. And one is this trapezium ABDE. It's a trapezium. And in a trapezium, we have 2 sides that are parallel to each other. And the question tells us that AE is parallel to BD. So these 2 sides are parallel, they are going in the same direction. And in a trapezium, 2 sides are not parallel. And those are AB and DE. Now the question says calculate angle BAE, which means that the angle is at A and it is between B and E. The angle is at A and it is between B and E. This is angle BAE and we have to calculate this. Now to calculate this angle, from this trapezium we have to make a right angled triangle so that we can apply the trigonometric ratios sine, cos and tan. Now let's see how to do that. Look at this trapezium. It has 2 sides that are parallel to each other and 2 sides that are not parallel to each other. Now if I draw a line vertically downwards from this point, then this angle over here will be 90 degrees and I'll get a right angled triangle over here. And if I draw a line vertically downwards from this point, I'll get a 90-degree angle over here and this will form a right angled triangle. So we can make 2 right angled triangles from this trapezium. Now the trapezium that we have in the question, ABDE. If I draw a line vertically downwards from point B, and let's call this point X. So now this is a 90-degree angle at X, and that gives us ABX as a right angled triangle, which means we can apply sine, cos and tan trigonometric ratios on this triangle. Now to apply sine, cos and tan, we need to know the hypotenuse, the opposite and the adjacent side so that we can apply SOHCAHTOA. Now this is the right angle in this triangle and the side opposite to this right angle is the hypotenuse. Let's mark it as H for hypotenuse. Now the opposite and the adjacent sides will depend upon which angle we are using or calculating. We need to calculate this angle. So the side that is opposite to it is the opposite side O, and the side that is right next to it is the adjacent side. Let's mark it as A for adjacent. Now we know the opposite and the adjacent, so we can apply SOHCAHTOA. Let me draw this triangle over here separately. Now the length of this side DE is 8 centimeters, and that means this side BX will also be 8 centimeters. So BX is 8 centimeters. Now this side AE is 21 centimeters. And this length from B to D is 16 centimeters. And that means this length is also 16 centimeters. To get this length AX, we can subtract 16 from 21 and we'll get 5 centimeters. So this length from A to X is 5 centimeters. Now we know the length of the opposite side O and we know the length of the adjacent side A. So we know O and A. From SOHCAHTOA we see that O and A come together in TOA, tan ratio. So we need to apply the tan ratio. Now tan of any angle X is equal to O opposite divided by A adjacent. Now the tan of our angle BAE will be equal to the opposite side, that is 8, divided by the adjacent side, that is 5. Now we need to move this tan to the other side, and on the other side we will get tan inverse. On the left side we will be left with the angle BAE, which will be equal to the tan inverse of 8 divided by 5. And if we evaluate it with the calculator, we'll get the angle BAE is equal to 57.995 degrees. And we can write it in the answer space as 58 degrees. Next, the question says that the area of pentagon ABCDE is 200 centimeters squared. That means the area of this entire figure is 200 centimeters squared. Calculate the length of BC for 5 marks. Now BC is this length, and we're given the area of this entire shape, that is 200 centimeters squared. Now to calculate this length BC, I can use this triangle BCD. The area of this triangle would be 1 by 2 multiplied by the length BC multiplied by the length 16 multiplied by sine of the angle that is between these two lengths, that is 65 degrees. So to calculate the area of this non-right angled triangle, I need two lengths BC and 16, and I need the angle that is between those two sides, that is 65. And to calculate the area, I can multiply 1 by 2 multiplied by those two sides multiplied by the sine of the angle that is between those two sides. Now if I have the area of this triangle, I can use this equation to calculate the length BC. But I don't have the area of this triangle. I have the area of the entire shape, that is 200 centimeters squared. And that means I need to subtract the area of this trapezium from the total area so that I can have the area of this triangle BCD. Now let's calculate the area of this trapezium. The formula for the area of trapezium is 1 by 2 multiplied by the sum of lengths of parallel sides multiplied by the height of the trapezium. Now sum of lengths of the parallel sides. The side BD is 16 and the side AE is 21, and these are the two sides that are parallel to each other. So we will add their lengths. 16 plus 21. The height of the trapezium is the distance, the perpendicular distance between these two parallel sides, that is 8 centimeters. Now 1 by 2 multiplied by 16 plus 21 is 37 multiplied by 8. Now this 8 is in the numerator and 2 is in the denominator, so we can simplify them. 2 1s are 2 and 2 4s are 8. We are left with 37 multiplied by 4, which is equal to 148 centimeters squared. Now we know that the area of this trapezium is 148. So from the total area 200 centimeters squared, I need to subtract the area of this trapezium, that is 148 centimeters squared. So I can get the area of this triangle BCD. An area of this triangle would be equal to 52 centimeters squared. Now I can use the value of this area in this equation to calculate the length BC. 52 equals 1 by 2 multiplied by BC multiplied by 16 multiplied by the sine of 65. Now 16 is in the numerator and 2 is in the denominator. We can simplify these. 2 1s are 2, 2 8s are 16, and we are left with 52 is equal to BC multiplied by 8 multiplied by sine of 65. Now 8 multiplied by sine of 65, I can move this to the other side of the equation and I'll have it in the denominator over there. 52 divided by 8 times sine 65 will be equal to BC. And using the calculator to evaluate it, I'll get BC is equal to 7.17196. And we can write it to 3 significant figures, and that is 7.17 centimeters for 5 marks. Now the next question from the same paper is about bearings. The diagram shows the positions of 3 ports A, B and C. So A, B and C are 3 ports. The bearing of port B from port A is 107 degrees. We are given the bearing of port B from port A. That is B from A. Now from A means from the north at A. This is A and this is the north at A. And bearing is clockwise, so it means clockwise from the north at A. So clockwise from the north at A to the line joining A with B. is the bearing of B from A, and that is 107 degrees. So bearing of B from A is 107 degrees. Now the first part tells us to calculate the bearing of A from B. So the order has been reversed. We are given the bearing of B from A, and we need to calculate the bearing of A from B. Now from B means from the north at B. Now this is the north at B, and the bearing would be clockwise from the north at B. So clockwise from the north at B to the line joining B with A. This is the bearing of A from B, and we need to calculate this. Now this angle, the bearing of A from B, can be broken down into many different angles. If I draw a south over here, then the angle between north and south is 180 degrees. Also, if I draw an east-west line over here, then the angle between north and east is 90 degrees, the angle between east and south is 90 degrees, and the angle between south and west is 90 degrees. And we need to calculate this small green angle, let's call it x. And if we add all these four angles, we will get the bearing of A from B. Now the bearing of B from A is 107 degrees, and we can break this angle down into two other angles. If I draw an east-west line over here at A also, then this green angle will also be equal to x. Because these two east-west lines are parallel lines, and these two green angles between them are the alternate angles or the z angles, and they are equal to each other. If one is x, the other is also x. Now this complete angle bearing of B from A is 107 degrees, and this angle between north and east is 90 degrees. So from this total 107 degrees, if I subtract these 90 degrees, I'll get angle x, which will be equal to 17 degrees. Now if this is 17, this is also 17 because these are alternate angles or z angles. Now to calculate the bearing of A from B, this complete angle, we have to add 90 plus 90 plus 90 plus 17 degrees. And the bearing of A from B would be adding all these angles, and that would equal 287 degrees. The bearing of A from B is 287 degrees for 1 mark. Now you may think that that is a lot of working for just 1 mark. There is also a direct method for computing this. Now we are given the bearing of B from A, that is 107 degrees. So the bearing of B from A is 107, and we need to calculate the bearing of A from B. Now B from A is 107, that is less than 180 degrees. So if it is less than 180 degrees, we need to add 180 degrees to calculate the reverse bearing A from B. And that will give us 287 degrees as the reverse bearing A from B. Now the next part tells us to calculate the length of BC for 4 marks. Now this is the length BC, and just by looking at this non-right angled triangle, I can figure out that we need to apply the cosine rule. Because the formula for the cosine rule involves all the 3 sides of the triangle, and it involves one angle of the triangle. Now we are given the length of 2 sides of the triangle, 132 and 176. And we need to calculate the third length BC. That means all the 3 sides of the triangle are involved in the calculation. Now we need to calculate just one angle inside the triangle. And for that we can use this information. The bearing of port C from port A is 192 degrees. Now C from A. We are given the bearing of C from A. From A means from north at A. And because bearing is clockwise, it means clockwise from north at A. Now this is A and this is the north at A. Clockwise from the north at A up to the line joining A with C. This is the bearing of C from A. And this is 192 degrees. Now we are also given the bearing of B from A, that is 107 degrees. So this is the bearing of B from A, and that is 107 degrees. Now using this information we can calculate this blue angle inside the triangle. If from this complete 192 degrees angle we subtract this 107 degrees green angle, 192 minus 107 degrees, we will get this blue angle. Let's call it Y. So Y will be equal to 85 degrees, and that means this angle inside the triangle is 85 degrees. Now we have an angle inside the triangle and we can use the cosine rule. And that will be cos of the angle 85 degrees is equal to the square of the sides that are adjacent to the angle 85. The sides that are to the right and to the left of the angle 85. That is 132 and 176. So 132 squared plus 176 squared. And then we need to subtract the square of the side that is opposite to the angle. And that would be minus BC squared. Divided by 2 times the adjacent sides, that are the sides to the right and to the left of the angle, 132 and 176. Now we can move this denominator to the other side of the equation, and we'll get 2 times 132 times 176 times cos of 85 is equal to the right hand side. Now to calculate BC, we will move minus BC squared to the left side of the equation to get positive BC squared, and we will move this entire term to the right hand side. And we will get BC squared is equal to the terms that are already on the right hand side, 132 squared plus 176 squared minus 2 times 132 times 176 times cos of 85. Now this will give us the value of BC squared. To calculate the value of BC, we need to take the square root on both sides of the equation. On the left hand side, the square and the square root will cancel out, giving us just BC. And the right hand side will be equal to the square root of this entire thing. And using a calculator to evaluate it will give us BC is equal to 210.5953 kilometers, and we can round it off to 1 decimal place, 210.6 kilometers, and we can write it in the answer space. Now we move to May-June 2024, Paper 2, Variant 2. And the question concerning trigonometry is this. The diagram shows a pentagon, and a pentagon has 5 sides. 1, 2, 3, 4, 5. So A, B, C, D, E is a pentagon. In the pentagon, AE is equal to 8 centimeters and AD equals 15 centimeters. So AE is equal to 8 centimeters and AD is equal to 15 centimeters. Now AE is this side and it's 8 centimeters, and AD is this length and this is 15 centimeters. Now we have a non-right angled triangle ADE, and in this triangle we know 2 sides 8 and 15, and we know one angle 120 degrees. Now let's draw this triangle separately over here. The question tells us to calculate the length ED, and ED is this length. Now this is a non-right angled triangle, and by looking at the figure we can figure out that we need to apply the cosine rule, because the formula for the cosine rule involves 3 sides of a triangle and 1 angle. Now we need to calculate this length ED, and we have the other 2 lengths 8 and 15. That means we can involve all the 3 sides in the calculation, and we have one angle 120 degrees inside the triangle. That means we can use the cosine rule. Now applying the cosine rule, we'll get cos of the angle 120 degrees is equal to the sides that are adjacent to the angle 120, the sides that are to the right and to the left of the angle. That is ED and 8. ED squared plus 8 squared, and we will subtract the square of the side that is opposite to the angle 120, and that is 15, minus 15 squared, divided by 2 times the adjacent sides that are ED and 8. And now we can move this denominator to the other side of the equation, but before that, cos of 120 degrees is equal to minus 0.5. So we can write minus 0.5 over here, and we can move this denominator to the other side. Times 2 times ED times 8 is equal to the right hand side. Now we can simplify this left hand side. Minus 0.5 times 2 times 8 is minus 8. So minus 8 times ED is equal to ED squared plus 8 squared minus 15 squared is equal to minus 161. Now we need to calculate the value of ED, but we have ED squared in the equation, and that means this is a quadratic equation and it needs to be solved like a quadratic equation. Perhaps we can apply the quadratic formula. Just to make sure you see clearly that this is a quadratic equation, let's write ED is equal to x, and that means ED squared will be equal to x squared. So in place of ED we will write x, and in place of ED squared we will write x squared. Minus 8x is equal to x squared minus 161. Now we move minus 8x to the other side of the equation and we will get this quadratic equation. Now to apply the quadratic formula, we can use a equals 1, b equals 8, and c equals minus 161. And we simply need to plug in the values into the quadratic formula. So this is what we get. Now this entire term inside the square root, 8 squared minus 4 times 1 times minus 161 is equal to 708. So the equation we get is x is equal to minus 8 plus minus under root of 708 divided by 2. Now this plus and minus will give us two equations, one with the plus sign and the other with a minus sign. Now the first equation will give us x equals 9.304, and the second one will give us x equals minus 17.304. Now because we are calculating the length ED, so we will ignore the negative value, and that means ED is equal to 9.304, and we can write it in the answer space for 5 marks.